This is 4D Virtual Try-On, a physics-aware path from a garment image to simulate on-ready clothing on a moving digital human. We start with the two-dimensional image. Garment semantics identify the class, visible construction, neckline, sleeves, waistband, pleats, and print. Learn sewing pattern priors and body measurements, then propose manufacturable panels and links. Because one photograph is ambiguous, these are explicit, editable hypotheses, not claims of perfect hidden pattern recovery. Next, a three-dimensional UNet produces a Signer distance field. Semantic panel evidence guides topology extraction, and CortexODE deforms the surface into an intrinsic shell while preserving material coordinates. Laplace-Beltrami operators make the representation less dependent on a particular triangulation. Physics enters before animation. A hypernode field conditions Kirchhoff-Love membrane and bending energy on material properties. The cloth and body become one four-dimensional scene graph, with positions and momenta advanced by a symplectic phase space solver. Gravity, body transport, Signer distance contact events, multilayer garment contact, and gauge frame friction all contribute to the next state. The route was not straight. Early templates did not match the images. A shell-only model looked rigid. Missing body dynamics caused floating and penetration. Hard metric projection produced sudden skirt expansion. Weak momentum transfer left the garment behind the walking body, while oversoft coefficients made it flutter like silk. We corrected those failures by putting the body mesh into the same dynamic graph, transporting momentum through three relative frames, moving material limits into the energy model, and resolving contact in local gauge frames. The fixed resolution showcase disables adaptive mesh refinement and avoids per-step metric projection. The comparison now shows both WebGPU runs in full. First is the stable contact and heavier material setting during one captured walking step. It suppresses excessive flutter and keeps the garment layers separated. Second is the early high flexibility branch. Its t-shirt and skirt form larger folds and respond more actively, while also exposing wrinkles, topology stress, and contact artifacts. The contrast is intentional. Flexibility is not a cosmetic animation slider, but the visible consequence of membrane, bending, damping, mass, momentum transfer, and friction coefficients. Both clips are direct Three.js WebGPU recordings of simulated mesh trajectories, not generated video. Codex with GPT-5.6 was our main engineering partner. It turned the research proposal into runnable modules, integrated upstream work, wrote tests, diagnosed repeated simulations, and helped refine topology, contact, materials, gate, and rendering. The result is an inspectable research prototype for physically meaningful virtual fashion, with the assumptions, failures, and physics exposed.